when volcanoes erupt, they can have different styles or types of eruptions that can occur. And these are named for the places where we have witnessed them happen, or the places where they typically happen. So there are things like the Icelandic style eruption or Hawaiian style eruption. But what I want you guys to realize is it doesn't only happen in Iceland or Hawaii or things like that. These are just a type of eruption named for a place where it typically happens. So let's look at some of these volcanic eruption types and see how they're different. So Icelandic style eruptions are usually what we call effusive. And effusive means that you don't have big explosions, you simply have lava kind of oozing and flowing out of the ground. That's effusive. Icelandic style eruptions erupt out of fissures. And probably the coolest thing they can have these things called fire fountains. And a fire fountain is where there's just enough pressure that the lava shoots out of the ground and then it lands and flows away. Probably one of the coolest fire fountains ever was in 1959 when Kilauea Iki in Hawaii erupted. And you can actually go onto YouTube and just write Kilauea Iki eruption, and you'll see this fire fountain that at its highest was higher than the Empire State Building is tall. But in any case, these Icelandic style eruptions can have some of these really awesome fire fountains. Now, we can also have what's called a Hawaiian style eruption. This is also effusive, except instead of that fissure eruption, we get a central vent, right? And these also can have fire fountains. And so if you want to see fire fountains, you want to go to an Icelandic or a Hawaiian style eruption. And that's where you have lots of basalt and just enough pressure to create the magma, the lava, shooting out of the ground, but not exploding out of the ground. Now, a little bit more explosive than either one of those eruptions is what's called a Strombolian style eruption. And these are mildly explosive. So, we're not getting huge, giant super volcano type explosions, but you are getting some explosions. And what happens is you have these very distinct booms, these distinct explosions of lava, and they can go 10 to hundreds of meters high, but they're not flying like way up high in the atmosphere. And this is named for Stromboli, which is sometimes referred to as the lighthouse of the Mediterranean, because Stromboli has been having these eruptions for thousands of years. And so kind of like a lighthouse blinks every now and then with a light, this would have this flash of one of these mildly explosive eruptions every now and then. So it's kind of the lighthouse of the Mediterranean. Now, a Volcanian eruption is even more explosive. This is named for Volcano, which is actually another volcano near Stromboli. And this moderately explosive event occurs when you have this kind of older plug, this older like solidified lava stuck in the volcanic vent, and gases are accumulating behind it and kind of break it and blast it out of the way. Now in this case, we're actually getting something called an ash column. Remember that photograph I showed you of Mount St. Helens where there was like gray going up into the sky? That's an ash column. And in the case of a Volcanian eruption, you can get an ash column that can go a few kilometers into the atmosphere. Now we have a Pelean style eruption, which is named for Pele, a volcano in the Caribbean. And this is an explosive eruption. So we're not talking mildly or moderately explosive, we are talking explosive eruption here. And what often happens in this case, you get a lava dome forming on the volcano, and then part of it collapses. And as it collapses, it reduces the pressure behind it that allows all of the gas and pyroclastics behind to expand outward, and this produces a very dangerous hazard we call a pyroclastic flow that we're going to go over in just a few minutes. What's interesting about this kind of eruption, though, is the ash all basically is focused blasting out along the ground. You don't get it going high into the atmosphere. There's no ash column. And then we get into the really impressive eruptions, like a Plinian eruption. This is, again, explosive. And the ash column can go as high as 50 kilometers into the atmosphere. And this means we're actually going above the layer of atmosphere called the troposphere, where our weather patterns are happening, and ash can go all the way into the stratosphere. This also creates pyroclastic flows. Now, the Plinian-style eruption isn't named for a volcano like the rest of these. This is named for Pliny the Younger. And he witnessed the eruption of Mount Vesuvius in 79 AD. He was near modern-day Naples and was watching Vesuvius erupt, and he had a very scientific mind. And so as he watched this eruption, he wrote down everything that he observed. And he tried to think about it, at least for his day and age, in a very scientific way. And so he's kind of one of the first eyewitness, careful recorded accounts of a volcanic eruption, and so the type of eruption that he witnessed bears his name, Plinian eruption. Now we can also have an ultra-Plinian eruption, which is absolutely cataclysmic. It's everything in a Plinian eruption and even more. So when we talk about those like super volcanoes, like if Yellowstone was to erupt again or another caldera-forming eruption was to occur, that would be one of these ultra-Plinian eruptions. And in this diagram, this is just a visual way of looking at all of those. Here's those effusive, non-explosive Icelandic and Hawaiian eruptions. There's the Strombolian one that's a little bit explosive, the Volcanian one. There's that Palaean one where everything's focused near the ground. And then there's the Plinian one where we get this ash column going very high into the atmosphere. All right. One thing we gotta know about humans is we like to measure things, right? When there's a natural disaster that happens, whether it's an earthquake or a hurricane or a tornado or something, we want to know how bad is it, how big was it, that kind of stuff. Well, the same goes for volcanoes. And the way we measure a volcanic eruption is using the Volcanic Explosivity Index. And this was developed in 1982 to describe the magnitude of eruptions. It uses a scale of 0 to 8. Don't know why they didn't do 0 to 10. Maybe they lost some fingers or something and counted to 8. But it goes 0 to 8. And the factors that they look at is the volume of pyroclastics, so how many pyroclastics were produced, how high did those get, so did they go 100 meters high, or did they go 10 kilometers into the atmosphere, or 50 kilometers into the atmosphere? How high were those, was that eruption column, and how long did the explosion last? Now this just measures basically explosive eruptions. So that is one of the drawbacks of the Volcanic Explosivity Index, which we do abbreviate VEI. The drawback is it doesn't really look at effusive eruptions. So in 2018, we had that major eruption of Kilauea in Hawaii that basically buried an entire subdivision and a whole bunch of other things under lava. But that would have had a very low VEI because that eruption was not explosive. However, it still had a big impact on people and the landscape. And so that is one of the drawbacks. This really only looks at explosive eruptions, doesn't look too much at those effusive eruptions. So here is a diagram basically showing our VEI from 0 to 8. And you get the general description of non-explosive and so on. And then you can see things like the volume of tephra, that's the volume of pyroclastics, the column height, right? I said that's another thing that goes in there. The duration. You don't have to memorize all of the things on here, but it does give you an idea of what goes into looking at the volcanic explosivity index. I do like the qualitative descriptions that people use on this, like gentle and effusive, explosive, cataclysmic. I mean, but then we get into terrific. Like, man, that's a big volcanic eruption. Terrific. Okay, really it comes from the root word terror, so it's probably is terrific in a terrifying way, not a like yay way. But anyway, there's our VEI. We have not had any VEI of 8 happen in my lifetime, or in fact, even in the last few centuries. But that then brings me to talk about hazards. Like, honestly, one of the big themes in environmental geology is how Earth wants to kill you, right? It's like there are all these different natural hazards, and Earth is a dangerous place to be. How can you understand those hazards and limit the danger to yourself? So let's look at the hazards that volcanoes pose. Now again, one of the first things people think of is lava hazards. Well, let's see how hazardous these can be. When lava erupts out of a volcano, like in Hawaii, most lava flows are slow. Most of them are not much faster than about 3 miles an hour. I walk faster than 3 miles per hour, so you should really be able to walk away from most lava flows. And then in addition to that, they tend to be very predictable. Lava is a liquid. Liquids flow downhill. So we kind of know where the lava is going to go. It's going to go downhill. Now, it is mostly, though, dangerous to structures. And I did put stupid people because if you do stupid things with lava, it will kill you. But mostly, lava flows are hazardous to structures because the structures cannot be moved. And that's exactly what we saw in 2018 in Hawaii in the most recent Kilauea eruption. We can see right there that that was my mom hanging out in Hawaii, and she liked the sign that let us know that the road was closed. This used to be a road, and the lava didn't care and flowed right over top that. This was the Wa'ula Visitor Center in Hawaii, and I think this is back in, I don't remember, I think maybe 89. I probably have the year wrong, but this is all lava right here. The visitor center was made out of wood. The extreme heat of the lava as it got close to that wooden visitor center ignited the wood. Visitor center got completely burned down from that. And that's the kind of dangers you can have from lava. Now, that being said, there is a volcano where the lava flows can be really terrifying, and that is near Ngongo in the Congo. The chemistry of the lava makes it incredibly low viscosity. So back in, it was the 90s, there was an eruption, and lava flows raced down the side of the volcano as much as 60 miles per hour. And sadly, a number of people died in that because 60 mile per hour lava flows you are not being able to run away from. However, I do want to say, that's not common. Most lava flows are incredibly slow. Walk away from them. All right, more dangerous than lava is a hazard that we call a lahar. Now, lahar is a volcanic mud flow. A volcanic mud flow can form on a volcano in 2 basic ways. You can have a direct lahar, which is where, remember those stratovolcanoes are really, really tall, and many of them, I think most of the photos I showed you had like snow at the top of them because they're like 12, 14,000 feet high. Well, now imagine if we have an eruption under all of that ice and snow. The eruption is going to melt the ice and snow. The ash is going to mix with that water, and it's going to race off the mountain. That's a direct lahar, where the lahar happens because of an eruption. You can also have an indirect lahar. These can occur long after eruptions have stopped. Basically, you could have an eruption that sent ash all over the landscape, and then later on you have heavy rain on that ash, and that heavy rain combines with the ash and races down the mountain. This actually happened after Mount Pinatubo erupted in the Philippines in 1991. For years and years after that, when they had heavy rains on the volcano, they still had lahars simply because of all of the ash around the landscape. Now, the good news about lahars is that they have a predictable pathway. Again, we're talking about a liquid. It's a whole bunch of ash and pumice and other pyroplastics mixed with water, so it's going to flow downhill, and it usually follows river channels. The bad news about it is these things are fast, usually like 30 to 70 kilometers an hour, and they can flow far from the volcano. When Mount St. Helens erupted in 1980, a few of the deaths were because people were caught in the initial explosion of the volcanic eruption. But most of the deaths occurred in lahars, because there were people in some of the river valleys, like 70 kilometers away, just fly fishing or something, didn't even know the volcano erupted when suddenly this lahar races down the river valley. And so that's why they can be dangerous. They can catch people unaware who are a good distance from the volcano and might not even know that the eruption has happened. Best way to escape a lahar, since it's going to be in the river valley, if you see one coming towards you, do not try to outrun it, but try to run uphill. Try to get higher ground, and that should hopefully keep you from being caught in the lahar. This is a lahar coming off Mount Ruapehu in New Zealand. This is a little picnic area right here. A river flows right through here. That's where the river should be flowing. You can see this lahar basically becomes a giant muddy flood, and that's what these are typically like. Now, what I call these volcanic mud flows, that's kind of the standard definition of them, but I want you to realize it's more than just tiny little ash particles that can be caught up in these lahars. These are lahar deposits from the 1980 eruption of Mount St. Helens, and you can see there's big tree trunks in there. Or here, these are lahar deposits, old ones from Ruapehu, where we even have giant boulders stuck in there. There's actually two lahars, one deposit here and one on top of it. And so while we call them volcanic mud flows, I want you to realize that it is a lot of ash and pumice, but as these things are going down the side of the mountain, they can be picking up whatever's in their pathway. They can pick up trees, they can pick up boulders, pick up houses, and just carry them with them. And in a little bit, we'll actually have a video of what one of these lahars looks like. But let's take a look at that video right now, actually. That's a good time to take a look at it. I need a quick drink, so I'm stepping out of the screen. There, hopefully now I'm not so dry. And my cat is here letting you know that he wants to say hi. Alright, so this is a lahar that occurred in 2007 from Ruapehu in New Zealand. And hey, there's that little picnic area. And notice just how this is this kind of gray, muddy flood. There's all kinds of debris caught up in it. And we're going to see a bridge pretty soon. Lahars can sometimes be strong enough to actually wash away bridges. You know, all the trees and crap in there. And these can be quite deadly natural hazards. Unfortunately, back in 1985 in Colombia, there was a relatively minor volcanic eruption on a volcano called Nevado del Ruiz. And unfortunately, this relatively minor volcanic eruption created a lahar that buried almost an entire village. I shouldn't even call it a village, it's a town, and killed something like around 30,000 people. So lahars can be very deadly natural disasters. So let's go back then and take a look at some other hazards that volcanoes can produce.